Hello, math friends. I am going to look at finding the domain for a rational polynomial where we have an inequality. So a couple of things we want to recall first. Some number greater than 0 means that whatever this is should be positive. So whatever x's that we choose to put in for our input must make this positive. So that's going to be a constraint on our domain. The other constraint that's going to be on our domain is that we can't divide by 0. So whatever x that we put in here, we can't have this denominator go to 0. So the first thing that we're going to look at is the denominator and make sure that we guarantee it's not going to 0. So we're simply taking the denominator out of the fraction and we're going to set it equal to 0 and solve for x. That particular number will not be included in the domain. So the denominator is x plus 4. We're going to set that equal to 0 and then solve for x. We subtract 4 from both sides, leaving us x equals negative 4. So negative 4 will not be in our domain. The next thing that we have to do is we have to find which x's that we can plug into here and get a positive result from that. And to do this process, we are going to use a sign chart. So in the top of my sign chart is, the top bar is like a number line. And then down the left-hand side will be the terms that are in our rational function. So our numerator is 3x minus 2. That's going to go in my chart. And then x plus 4 is going to go in my chart also. And then for the bottom, this is kind of like my quotient line down here. It's going to be the whole fraction. So this is my entire left-hand column. Across the top here, this is going to be a number line. So over on the left-hand side, we have negative infinity. On the far right-hand side, we will have positive infinity. Somewhere in between here, we are going to have a negative 4. And we also need to know this numerator, where it is going to be critical. And so what I'm going to do here as another side calculation, just like I did a side calculation for the denominator, I'm going to take the numerator and I'm going to set it up with the inequality here so that this numerator is greater than 0. So I'm guaranteeing that my numerator is positive, and then I'm just going to solve this for x. And that's going to give me another critical point. So I'm going to add 2 to both sides, giving me 3x is greater than positive 2. And then I'm going to divide both sides by 3. So x must always be greater than 2/3. I'm going to add that to my chart. Now remember, the bar across the top, that is like a number line. I'm going to put some vertical bars below these critical points here. And also, I'm going to put a double bar here. We know that negative 4 is definitely not in our denominator, so that double bar is just to remind ourselves we are not going to include that number in the domain. The next thing that I'm going to do is I'm going to go through and I'm going to choose random numbers from these intervals and plug them into each of these and then write down just the sign that we get. We don't care about the number that we actually get, it's the sign that's important. This is a sign chart. Strictly the sign that we're looking for. So negative 5 would be the next integer value that's between negative 4 and negative infinity. If I plug negative 5 into here, I have 3 times negative 5 is negative 15. Negative 15 minus 2 is negative 17, so that is a negative number. So in my chart is going to go a negative. If I put negative 5 in here, negative 5 plus 4 is negative 1, so that's also negative. And we're going to do that across the top here. Between negative 4 and 2/3 is 0. 0 is a good number to plug in. If I do 3 times 0 gets 0, I'm left with negative 2, so I have a negative again. If I put in 0 here, 0 plus 4 is 4, that's positive, so I have a positive here. And then over here, I have 1 that I can choose. 1 is the next integer bigger than 2/3, so that's a nice number to use to calculate as well. 3 times 1 is 3, 3 minus 2 is 1, so that's positive. And then 1 over here, 1 plus 4 is 5, that's positive. And now I said this bottom line was my quotient line. I'm going to look at, if I have a negative divided by a negative, well, what do I get? Negative divided by a negative is positive, so I have positive here. Negative divided by positive is a negative, so I have negative here. And positive divided by positive is another positive, so I have positive here. Now that I have my quotient line down here, I need to go back and revisit what am I looking for my domain. This rational function is greater than 0, and so I'm looking for positives. So I have 2 positives in my quotient line. I have this first one and this second one. So in my first one, which interval is this? Well, this is negative infinity to negative 4, but not including negative 4. So in interval notation, we're going to have a parenthesis, negative infinity, comma, negative 4, parenthesis. Now I also have the interval over here of the positive. And since this is not greater than or equal to, any place that it's a 0 is also not in the domain. If I plug my 2/3 into this first one, I would get a 0 here. And so we don't include 2/3 as a part of this domain either. So we're going to start with 2/3. That's going to be a parenthesis bracket. And we're going to have that run to positive infinity. And between these two intervals, we're going to put the union symbol because we want to use both of these. And that will be our entire domain for this rational function inequality. Cheerful calculations.